Okay, so in this problem 2 by 13, again, this is taken from the Gelmarium book. So in a Pinewood Derby event shown, the car is released from rest. It is starting position A. So the car is released from rest. So this means that the initial velocity or VA is equal to 0, and then roll down the incline and onto the finish line C. So the car is coming here and then going to this location here. If the constant acceleration down the incline is 2.75 meter per second, so A is constant here, and which is 2.75 meter per second square. And the speed from B to C is constant. So the speed from B to C is constant. So this means that A is equal to 0. So the acceleration is 0 from B to C. Determine the time duration TAC for the race. So the requirement here is that you need to calculate the TAC. The effect of a small transition area from B at B can be neglected. So this transition, when the car is moving in this direction and then it's changed direction, so we can just ignore this. So you need to calculate the time that the car will take from A to C. So obviously this TAC can be split into two times. So TAB plus TBC. We can solve this into two steps. So solution. Okay. So as you can see, from A to B and from B to C, the acceleration is constant. So here the acceleration is 2.75, and here is the acceleration is 0. So this means the acceleration is constant here and constant here. So then we can simply use these equations, and these equations were derived in the theory. And these equations will be available as a formula sheet in the exam. So you will have access to these equations. So as you can see, from A to B, you are given that VA equals 0, but the velocity at B is unknown, and also the time is unknown. So if you look at these equations here, so you can use the second equation to calculate the velocity at B. And then you can use the equation A to calculate the time. So if you look at the equation 2 here, so if this is our equation 1, equation 2, and this is equation 3, we can use equation 2. Equation 2 will provide that v square. So this means that the final velocity, which in our case is vb, if we consider motion from A to B, if we consider this motion initially from A to B, we can say that the final velocity, which is vb, equal to the initial velocity, which is va, and these are square, plus 2a and s minus s naught. So vb square equal to 0 plus 2, and the acceleration is given, which is 2.75, and s minus s naught. So at A, the s is 0, so s naught is 0 here, and at B, the s is 3, so this will be 3 here. So now from this equation, you can calculate the value of VB, which will be equal to 4.06 meter per second. So now if you know the velocity at location B, now you can use the first equation here. So which is again, if you use the first equation, the first equation is that is VB equal to VA and plus AT. So VB is 4.06, VA is 0, and plus 2.75 into t. So from here you can calculate t, which will be equal to 1.477 second. So this t is obviously the time from A to B. Okay, so if you know the time from A to B, now we can calculate the time from B to C. So now consider motion from B to C. We know that the distance here is 4, and the velocity at B is 4.06. The velocity at C is obviously 4.06 because the acceleration is 0. So now we need to calculate again the time here, and obviously you can use different equations here. So the first equation you cannot use because the acceleration is 0, and the velocity 1 and 2 are the same, so this will be useless. Now you can use the third equation here, so which is s equal to s naught plus v naught t plus half at square. So s here is 4. S naught, if you consider the motion from B to C, so S naught will be 0. V naught will be the initial velocity at B, which is this 4.06. And time here is unknown. That is what we want to calculate. So that will be the time from B to C. And the acceleration from B to C 0. So this means that this term will become equal to 0. So plus 0 because acceleration is 0. So from here you can calculate TBC, which will become equal to 4 divided by 4.06, and which will become equal to 0.985 second. Okay, so now you know the time from A to B and the time from B to C. So now you can use this equation here. So the total time, which is this TAC, is equal to 1.477, which is the time from A to B, and then the time from B to C, which is 0.985. The total time here will be 2.46 second.